So hello everyone. Today in this video we are going to study intrinsic and extrinsic semiconductors. So yes, semiconductors are one of the three materials we have studied, that is conductors, semiconductors and insulators. So these three materials are getting divided on the basis of the energy band, okay, that we have studied in the last lectures. So in this series of the study of electronics, I have explained everything like from neutron, proton, electron, the orbits, energy band, and on the basis of that how we have divided the material into three types. And yes, I said in the last lecture also, in the electronic devices, all the electronic devices are made up of the semiconductors. And why semiconductors? Because in semiconductor insulators there's no electrical conductivity, and in conductors there is conductivity, but it's not in control. Okay, semiconductors are only one type of materials wherein we can change the control, we can change the flow of current, we can control it. And what is important in the electronics is the controlling part. Okay, electronics is based on all about controlling of the charges, all about controlling of the electrons and holes. So semiconductors are only the one who have the capability of controlling it. And how we are controlling that we are going to study. This intrinsic and extrinsic are not the two types, you can say. There's two behavior, how semiconductors behave in the intrinsic form and the extrinsic form. Okay, let's just start with this intrinsic semiconductor. Okay, intrinsic semiconductors, let's just study one by one. Semiconductor in an extremely pure form is known as the intrinsic semiconductors. So in a semiconductor we have studied the silicon and germanium in the last video, that I have told you that silicon we got from the rock and sand, and the germanium we got from the coal ash, etc. So whenever we are getting these materials from this earth element, so these are not in a pure form. Okay, they come with along with the impurity. So we have to get it pure form in order to study them, in order to study their crystalline nature. So yeah, so by using modern technology we get the purest form of the semiconductors, and that purest form is known as the intrinsic semiconductors. So what exactly happens in the intrinsic semiconductors? We'll just have a quick review. In an intrinsic semiconductor, holes and electrons pairs are created at the room temperature. This also thing that we have already studied. The room temperature is a kind of a thermal energy which then excites the electrons and breaks the covalent bonds. And whenever this electron is set free, simultaneously hole is also created. Why and how this whole current, everything that I have studied, I've given everything in detail in the last video. If you haven't watched, please go and watch. Because of that, you will get clarification about every point. Okay. So conduction in intrinsic semiconductors happens through both free electrons and holes. This is the most important, you can say, the characteristics of the intrinsic semiconductor is that the current in the intrinsic semiconductor, it happens because of these electrons and holes. And how is that? We'll see in the next slide. Basically, you should know these free electrons are produced when the covalent bond breaks due to the thermal energy that I have told you already. So at the same time, holes are also created, okay, in the covalent bond. So you can say the total current in the intrinsic semiconductor is the sum of the current due to electrons and due to holes. And how is this? Just see here. I have drawn here one simple diagram for your sake of understanding, wherein this box represents a semiconductor material. These are the conducting wires, okay, and this is the battery, this is the source, okay, wherein this positive long and this is short one is the negative terminal. So what happens? This semiconductor consists of both holes and electrons. Electrons are shown by here red, and the red arrow the direction of their flow. Holes are represented by the yellow, and the yellow arrow the flow of the holes moves towards the negative terminal while being positively charged. Now what happens? I'll just tell you one by one. What is the process of this? Let's consider these holes are there in this, okay, semiconductors. Holes are having the positive nature. Why positive nature? Holes are nothing but the absence of electrons. When there's no electron, this is called as holes. So electrons are negative charge, so absence of electrons is considered here as a positive charge. Okay, so holes are being positive in charge, definitely they will get attracted towards this negative terminal of their battery. Okay, so when the holes reach the negative terminal, electrons enters the semiconductor crystals and combines with the holes and cancelling them out. So when I am saying the holes are coming towards here, it this means that the electrons from this negative terminal are entering through this crystal. Okay, this meaning is one and the same, and if you'll get to know this very detail if you go and watch the last lecture. Okay, if in every lecture I will start to explain everything in detail, it will be very time consuming. So for that, so loose electrons near the positive terminals are attracted towards the positive terminal, creating new holes near it. Now what I said, because of the holes positive in nature, they are getting attracted towards the negative, and that means that the electrons from this negative terminal are entering through this crystal. What happens next? What happens next? So there are some electrons which are loosely bound to the nucleus in the covalent bonds. So these electrons having negative in charge, so they will get attracted towards this positive terminal of this battery. Okay, so these new holes then drift towards the negative terminal. So when the electrons are coming from here to here, okay, so what will happen? They will create the holes over here, because when the electron is moving from position A to B, the electrons is reaching to B, it is creating hole near A, in a place of A. So again it is creating hole. Again the holes are getting transferred to over here. Electrons will come here, and the loosely bound electrons along with this will get attracted towards here. This process again creates holes. So this is continuous process. If you haven't understood, please go and rewind this and watch again. This is the advantage of having the digital lecture. So we'll see the extrinsic semiconductor. Now what is extrinsic? X means for the external material. Now what is external material and why it is needed? We'll see in detail. Semiconductor material that has been subjected to a doping process is called an extrinsic material. You should first know the definition of it, okay? And then your job is to just go on get details of every word of the definition. Okay, you should know the extrinsic materials. What? Semiconductor material that has been subjected to a doping process. The word doping process is very important. Why this is important and what is that, we'll see in detail. So intrinsic semiconductors have limited conductivity at the room temperature, that we have seen. There are limited number of free electrons, and these free electrons are creating limited number of current, and because of that we are having a limited amount of current. I want large amount of current. I want to enhance this conductivity. Okay. To enhance their conductivity, small amount of impurity is added to create the extrinsic semiconductors. Yes, you're right. When the semiconductor materials are found in the earth crust, they found in impure form. We are getting them pure, which we are calling is extrinsic. Now we are again adding some impurity purposefully, and the impurities are decided by us because we know what we want the result. Okay, we what the result we are expecting. So for that we are adding a small amount of impurity. Okay, impurity is getting added. So what happens because of that? Because of that the band structure, okay, semiconductors, conductors, insulator all together are getting divided on the basis of the band structure. Okay, so because of the impurity, band structure is getting changed. Because of that, electrical property of the material is going to change. Okay, and you should know the process of adding this impurity is known as the doping. Doping process means we are adding impurity. Why we are adding impurity? Because we want to change the electrical property. Now impurities are carefully controlled to ensure the desired properties. Now it is not like that you take impurity and just place it on the semiconductor. See here, usually one impurity atom is added for 10 to the 10 raised to the 8 atoms of semiconductor. So this is very fine process. This is done by the modern technology, and by doing this what we are doing, what we are achieving, the purpose of adding impurities to increase number of free holes or free electrons or holes in the semiconductor crystals. Okay, we know that the electrons are holes, both are responsible for the flow. Okay, see, current is nothing but flow of charge is nothing but electrons and holes. So when you want to change the current, you have to deal with these electrons and holes, number of electrons and number of holes. And why we are doing this? Because we want to enhance the property of these semiconductors. Okay, that's why we have added this impurity. Now till now what I am using, I am just using the word impurity. I haven't said which kind of impurity I am adding, and because of that what is happening, if a impurity is adding, after addition of the impurity I am getting only free electrons, so that is nothing but n type. If I'm adding the impurity I am getting free holes, that is p type semiconductors. Okay, so there are some different types of impurity. Because of that we are getting n-type and p-type semiconductor, which are the core basis of all the electronic devices in the next chapter that we are going to study. So till now, I hope you have covered everything very nicely. If you haven't, please rewind this lecture and watch again and again. So here in the tabular form, I have given the quick revision and your difference. See, doping. Intrinsic, there's no dope. What is doping? Doping is the process of adding impurity. Extrinsic, yes, it is dope with the specific impurities that we have chosen. That we'll see in the next lecture. Carrier concentration, yeah, electrons and holes, both are same. Carrier means what? The charges, electrons and holes, positive, negative, both are same. Here, either electrons will be higher or the holes will be higher depending on the impurity. Conductivity, yes, it is very normal. It is very poor conductivity, you can say. Extrinsic, enhanced, okay, we can increase the conductivity. Charge carriers, both holes and electrons. Charge carriers means the current is because of both the holes and electrons. And here the current is because of majority charge carriers. Majority means the charge carriers who are having the larger number, okay, and the who are having the lower number is a minority carriers. The majority is N-type electrons and P-type holes. That we'll see detail in the next class. So energy gap, fixed energy gap depending on the material type. We have studied this energy gap, right? And this is energy gap can be engineered by the choice of dopant. Okay, this is very nice thing. So temperature dependent, strongly temperature dependent. Why? Because of thermal energy. We know that at room temperature, the electron hole pairs are getting created. Because of that, it produces current. So it is dependent on the, but it is designed in such a way that it is less temperature dependent. See, every electronic device or everything that we are doing is to achieve less temperature dependent. Okay, we don't want our device or a circuit to change in any temperature. Okay, that is the motive of these electronics. So yeah, extrinsic is less temperature dependent. Applications, even the intrinsic semiconductor don't have any particular applications because of their characteristics. Still, we can use them in research lab for the higher study purpose, education, fundamental semiconductor science. Okay, on the basis of that, many results can be achieved, which can be helpful for the advanced electronics field. So yeah, extrinsic is everywhere. Electronic devices, rectifiers, transistor, diodes, everywhere. The examples are like semiconductors, pure semiconductors, pure form, the purest form of the semiconductors come into the intrinsic semiconductors, and extrinsic means, yeah, all the devices that N-type, P-type, silicon, germanium, N-type, P-type, yeah. So these comes under the extrinsic semiconductors. So I hope you have understood the intrinsic and extrinsic semiconductor. If not, please go and you can get the speed low in order to get the frequency of your learning. Because of some time limitations, I'm just using fast words and fast slides, but for your convenience you can do rewind and slow speed, etc., the features that are available on the YouTube. And thank you so much for watching this video. If you have any doubt, please comment section me